Alright, in this video I'm going to look at applications of quadratic equations. We've solved several quadratic equations in this section, and so now we're going to do a couple of applications. Number 20 and number 22 are the two that I expect everybody to be able to do. Number 21, certainly it's a problem that, if you want to challenge yourself, it's really more challenging because it's just a little bit different and the numbers are a little bit bigger. But we're going to focus on 20 and 22 in particular, and 21 is kind of optional. All right, so let's go ahead and do this. So it says a rectangular parking lot, let's go ahead and put one in, has a length that is 3 yards greater than the width. So it's comparing the length to the width. So if I know the width, then I can write the length in terms of the width. So the width, let's call that W. So usually we let the longer side be the length just to be consistent. So it says the length is 3 greater than the width. Well, using W, we can just write it as W plus 3. So our width is W, and our length can be written as W plus 3, since the length is 3 more than the width. Alright, we also have a formula for area, which is what we're dealing with here. It's area equals length times width when you're working with a rectangle. So our length times width, that's going to be W times W plus 3. Doesn't matter which order you write it in. It says that's equal to 180. And so we're supposed to find the length and the width. So let's go ahead and solve this. We've got some distributing to do, and that's equal to 180. Let's get the 180 on the other side by subtracting 180 on each side. And so this is the equation that we need to factor. So we need two numbers that multiply to negative 180 and add up to 3. So if you play around with the numbers, you'll find that 12 and 15 work. And we need to make the 12 negative and the 15 positive. So you can double check the work here, but those two numbers work. Now, because this is a 1, we know that we can just plug those in. So we're going to have W minus 12 times W plus 15. And so we're going to get 12 and negative 15. Now think about this. We're looking for width. So certainly width can't be negative. So we know our width is 12, and to find the length, we just plug in 12 for since it's W plus 3, it'll be 12 plus 3, which means our length is 15. So our final answer here is we have a width of 12 yards and a length of 15 yards, because we are working in yards here. All right, let's look at 21. Again, this is the optional problem. So it says a vacant rectangular lot is being turned into a community vegetable garden measuring 15 meters by 12 meters. I'm going to go ahead and draw the picture here, the basic picture. It says a path of uniform width, whoa, that got spelled wrong, should be width, is to surround the garden. So we're going to call that width X. So all the way around the outside of the garden, you have this uniform path. In other words, the width will be the same all the way around. And actually, I'm using X to represent the width of that path. And so it says that, let's see, that's not what I wanted to do. Actually, let me go back here. So you can see down below it says the area of the garden and path combined is 378 square meters. So this combined area of all through this whole rectangle, including the path, is what's 378 square meters. So we need to find the length and the width. So notice the length here is made up of the triangle, the inner triangle, rectangle, which has a length of 15, and then we've got these two x lengths, and so that whole length there is going to be 15 plus 2x. So the 15 is basically the red length there plus 2 x's, and that makes up that whole length of the path and the garden combined. Let's look at the width. So it's going to be very similar. We've got 12 plus 2 x's here, and so that's the width. So we know length times width is going to be 378. So there's our length and our width, and we got some distributing to, we got to FOIL that out, which is what I did there. Let's combine our like terms. So that gets us a little more simplified. Let's see, we're going to need to get 0 on one side, so let's subtract 378 from both sides. We get 4x squared plus 54x minus 198 is equal to 0. Now notice those are all even numbers. In fact, 2 is a GCF. And if we have 2 times this trinomial equal to 0, it's not because of the 2. 2x squared plus 27x minus 99 is what needs to be set equal to 0. That's what's equal to 0. So I'm just going to go ahead and factor this. The thing that makes this harder is the numbers are bigger, but you just use your calculator to help you, and it takes a little more time to find the factors. But when you factor it, you end up getting 2x minus, or plus 33 times x minus 3. Now for the first factor there, when you solve for x, you get, or set it equal to 0, you're going to get x equals negative 33 over 2. And we know that length or width, in this case we're looking for x, which is the width of the path, can't be negative. So our answer is going to be just 3. And so the length of the path is 3 meters. All right, let's move on to our last problem. It says a ball is thrown downward from the top of a 200-foot building with an initial velocity of 20 feet per second. The height h of the ball after t seconds is given by this equation here. How long after the ball is thrown will it strike the ground? So notice, now keep in mind, be careful here, the 200 foot and the velocity of 20 feet per second, that's already built into the equation. All we're concerned about is height and time. In a problem like this, we're going to be given the height or the time, and we're going to have to find the other variable. So it says how long, so basically we're looking for time here, which means we must have the height. Well, it's kind of hidden, but we're given the information we need to know what the height is. This tells us, this equation tells us the height after t seconds. Well, when it hits the ground, the height from the ground is 0. And so we actually know that h is equal to 0. So let's plug in 0 here. Whoops, let me get that t out of there. I gotta go back. Sorry about this. All right. So, first of all, notice we got that minus 16t squared out front, or the minus 16. We're going to be able to factor, let's see, it looks like it's going to be a 4. And because our first term is negative, we actually want to factor out a negative 4. So when we do that, we're going to end up with 4t squared plus 5t minus 50 inside. Be really careful with your signs when you do this kind of thing. If you double check it by distributing, you can see that this is equal to what we started with. And I'm just going to go ahead and use the quadratic formula. Basically, we have 0 equals -4 times this trinomial. Well, we're not getting 0 because of the -4. It's this trinomial that must be equal to 0. So I'm going to set that equal to 0. And I'm going to use quadratic formula. So we got A is 4, B is 5, and C is -50. And there's our quadratic formula. Notice I'm not using x, I'm using t since that's the variable we're working with. Let's plug in the numbers. Of course, if you haven't already stopped the video to do the problem, this might be a good time to at least simplify it and see if you get the same answer I do. You want to get a decimal answer here. I'm going to go ahead and finish this out. So we get -5 plus or minus, you should get the square root of 825, and that's over 8. So there's going to be two answers, -5 plus the square root of 825 over 8, and of course the minus case. So let's do the addition. If you throw that into your calculator, you should get about 2.965, which is pretty darn close to 3. We're just going to call it 3 seconds. Now, if you actually plug in the other, you'll find that you get a negative number. And so this is our only solution, 3 seconds. And that's going to be it for this video.